Welcome back to the Neuro Symbolic Channel. I'm Paulo Shakarian, and today going to be doing a virtual poster talk. I am actually on my way right now, is the time of this recording, to the NESI conference, which is now the premier venue for neurosymbolic AI. It used to be a workshop, and recently it became a full-fledged conference. So this is the first year it's now considered a conference and not a workshop. And in this video, I'm going to quickly give you an overview of the poster that I will be presenting at this conference this week. The conference is in Barcelona, Spain, so I know a lot of you who watch the channel probably won't get out there, so I thought I'd share with you this paper. Now, this is a position paper. It's more giving kind of our ideas about a larger way forward, and it's written with my colleague Hua Wei out of Arizona State, who is really promising assistant professor who's rapidly making a lot of progress in his career. My good friend Christian Libier, who is really well known for his work on cognitive models. Christian's out of Carnegie Mellon. We've worked together for a number of years. Bruce Draper, who's a former DARPA program manager, who was focused on metacognition at DARPA, and now he has since left DARPA because they have limited terms there, and he's back in his faculty position at Colorado State. Nikhil Krishnaswamy, who is also at Colorado State, who's doing work in this area as well. And then Sergey Nirenberg, who is at Rensselaer Polytechnic out in New York, also does a lot of work kind of at the intersection of cognition and AI. So, really honored to be on this paper with such an established group of individuals. It's really kind of neat to see, we have Christian, Bruce, and Sergey on this paper with us in particular. So the idea here is we talk about a general framework for metacognitive AI, and we make the case why neurosymbolic AI is a way to help us reach metacognition. And so in the poster, we introduce this idea called the TRAP framework. And TRAP stands for transparency, reasoning, adaptability, and perception. And these are sort of 4 criteria around metacognition that we believe a metacognitive system should have. And then we talk in the paper about why neurosymbolic AI is a good fit for this. And when you think about it, neurosymbolic AI, it can afford potentially a lot of transparency because of how it relates logic or other symbolic methods with vector representations, reasoning, because that's inherently the point of neurosymbolic AI, is to wed perception and reasoning, as well as things like adaptability. And in particular, a couple lines of research we call out in particular with regard to neurosymbolic AI that seems to be heading toward this more metacognitive construct. One that I really like and have talked about on, actually I like all of these, that I've talked about on the channel is abductive learning. Here is where abduction is used to sort of fill in the gaps between reasoning and perception, primarily focused on changing the model weight so they can meet the symbolic knowledge that pre-exists. The other is NASR, which my good friend and colleague Christina Cornelio has worked on in an iClear Spotlight paper published about 2 years ago. Here she talks about training a transformer model that is designed to detect errors in the neural model, so it can conform better to a symbolic reasoning level. And some of the work out of my lab, EDCR, error detection and correction rules, which is very recent, And we talked about this on the channel before, where you learn logical rules to correct the model as opposed to the other approaches that tend to be focused more on adjusting the perceptual model or having a neural-based model for correction. So these approaches, it's not exhaustive, but they kind of run the spectrum of how you make these corrections, where ABL primarily is used to correct the perceptual model. NASR is kind of in between, where it is creating a neural model that's designed to fix perception. And EDCR, you have a totally symbolic layer to correct the perception, and you sort of consider the perception model as fixed. And so going forward in this area of applying neurosymbolic AI to metacognition, there's some challenges. So mainly is generalization to diverse and dynamic environments. How do we push these models toward continuous self-improvement? Of course, there's always ethical concerns. So how can we link metacognition, how we think about how machines make decisions, to moral and ethical requirements? Interpretation of the metacognitive processes, as well as benchmarking, is very difficult. I mean, it's even difficult to talk about measurement, because the measurements become a little bit different than standard machine learning, where now you talk about things like, hey, what is the precision and recall of identifying the errors, which is different than precision and recall of the underlying model. And what are the appropriate metrics that we should build toward? And so this kind of sums up this poster. Again, just wanted to have this short video for those of you who can't attend the conference to understand what we're doing. And if you are attending the conference, I look forward to seeing you. Thank you very much.